So the next question is to prove determinant 1, 1, 1, a, b, c, a cube, b cube, c cube is equal to a minus b minus c into c minus a into a plus b plus c. So we will take the LHS. Determinant 1, 1, 1, a, b, c, a cube, b cube, c cube. The specialty of the determinant is one row completely is 1. So if a question comes like this with the one row complete terms are 1, what you have to do is keep 1 1 as such and make the other two ones 0. So to make this one 0, what we can do is C2 changes to C2 minus C1. Again, this one is in the third column. So to make this one 0, what we can do is C3 changes to C3 minus C1. So those transformation I am doing. C2 changes to C2 minus C1 and same way C3 changes to C3 minus C1. So first column remains the same, 1 a cube. Okay, what will be this column? 1 minus 1, 0. Here it is b minus a. No change, it is b minus a itself. And what about the third one? It is b cube minus a cube. Again, third column, 1 minus 1, 0. C minus a. And the third one is c cube minus a cube. So this is equal to 1 a cube. And in the second column, first term is 0, second term is b minus a, and instead of b cube minus a cube, we have a formula a cube minus b cube is equal to a minus b into a square plus ab plus b square. There was one factorization which we studied in previous classes. So instead of b cube minus a cube, we are going to factorize it as b minus a into b square plus ab plus b square, a square. First term and the second term you have to write as b minus a, then square of the first term plus the product of these two terms plus the square of the last term, it is a square. Same way, third column 0, c minus a, and instead of c cube minus a cube again factorize c minus a into c square plus ac plus a square. Again, look at the second column. In the second column, the elements are 0, b minus a into this term. In the third column, the terms are 0, c minus a into a term. So in the second column, what is common? B minus a is common. Take it outside. And from the third column, I am taking c minus a outside. So what is the balance determinant? 1 a cube in the first column, 0, 1 because we took b minus a outside. And the third term will be b square plus ab plus a square. What about the third column? It is 0, c minus a came out, it is 1. And the third element is c square plus ac plus a square. Again, what we are going to do is, we need a b minus a. C minus a also we got here. Okay, again we need a b minus c and this term a plus b plus c. For that, what we are going to do is we are again applying a transformation. C3 changes to C3 minus C2. C3 changes to C3 minus C2. So b minus a into c minus a into determinant. First column 1 a cube. Second column 0, 1 b square plus ab plus a square. Third column 0 minus 0, C3 minus C2, that is 0, 1 minus 1, that is again 0. And what about this element? This element is actually c square plus ac plus a square minus this term, isn't it? So all these terms become negative. So minus b square minus ab minus a square. In that, minus a square and plus a square gets cancelled. And I am rearranging the term. I am taking c square and b square together. So I am writing c square minus b square together. Okay. And the other two terms ac minus ab together plus ac minus ab. Okay. Then what I am going to do is, already b minus a is there outside. C minus a is there outside into determinant 1 a cube 0 1 b square plus ab plus a square is the third element. 0, 0. Instead of c square minus b square, I can write the term as c plus b into c minus b, isn't it? This is of the form a square minus b square, so we can factorize again as c plus b into c minus b. And from these two terms, second and the third term, I am taking an a outside. So what will be the balance? From this term, the balance is c, and from this term, it is minus b. Clear? Actually, the term is c square minus b square. It is of the form a square minus b square. So factorize as a plus b into a minus b. Second and third term, I took it together and I took a common a outside. So the balance is c minus b. Now we have two terms, c plus b into c minus b and a into c minus b. What is common there? The common term is c minus b. I am taking the common term and writing here. So c minus b into balance c minus b came out. The balance in the first term is c plus b. And in the second term, from the second term, c minus b came out as common. And the balance is plus a. Okay, again I am going to expand. So instead of b minus a, I am taking a negative outside. So it will give you minus of a minus b. C minus a, I am taking a c minus a itself. And look at the first row. First row contains only one row. So expansion is very easy. Just to expand using the first element. So if I expand using the first element, 1 into the balance product. 1 into any number gives you the value 1. So no need to write that. Apply. Take the product of main diagonal elements. So 1 into c minus b into c plus b plus a gives you c minus b into c plus b plus a. Minus 0 into this term gives you 0. Okay. What I did is I expanded using the first row. So first row, first element is 1. 1 into, avoid the row and the column containing 1. So the balance 2 by 2 matrix is 1, 0, b square plus a square plus ab and this term. So main diagonal, the product of the main diagonal element is 1 into c minus b into c plus a. That I wrote minus of diagonal element 0 into any term will give you the value 0. Okay. Again, instead of c minus b, if I took a negative outside, that will become minus of b minus c, isn't it? This negative and this negative together will give you positive. So I am getting the term a minus b into, the next term is c minus a into, actually this term into minus 0 gives you this term c minus b into c plus a plus b. And from that c minus b, I took a negative outside and I got b minus c. So the term is actually b minus c into a plus b plus c. This negative and this negative together makes you positive. So we are getting a minus b into b minus c into c minus a into a plus b plus c, which is our RHS. So hence proved. That was our RHS which we need to prove. Okay.